Okay, so we will continue with review problems of chapter 2. We have reached problem 7. In problem 7, we want to determine the position XY0 for the fixing cable BA so that the resultant of the forces exerted on the pole is directed along its axis from B towards O and has a magnitude Fr. Also, what is the magnitude of force Fc? So let us look at the figure. What we have here, we have three forces acting on point B. We have F1, F2, and F3. And we want that the resultant of these three forces should be along BO. It should be directed from B towards O. Okay, this is the question. Now, what is given, we know the magnitude of F1, which is 500. We know the magnitude of F2, which is 400. We know that the resultant force has a magnitude of 1000 Newton. So the only unknown in magnitude is F3. Okay? F3 is not known. Now, concerning the points, the different points here, we know the different coordinates through A, B, C, D, but we don't know for point A, we have two unknowns. For point A, we don't know what is X, and we don't know what is Y. So in this problem, we have three unknowns, F3, X here, this distance, and Y. Okay? And whenever you have a 3D problem and you can write a vectorial relation, because the vectorial relation you can write here is that the resultant force is equal to F1 plus F2 plus F3. This vectorial relation will give you three equations, one in X, one in Y, one in Z. And you know that whenever I have a system of three equations with three unknowns, I can solve. Okay? Now look, this example is a little bit complex for the solution. So what I want from you is just to reach the final system. No need to resolve. The important for me is to reach the set of three equations. How to reach the set of three equations? We start first by writing the vectorial relation, which is F resultant as a vector is equal to F1 vector plus F2 vector plus F3 vector. Okay? And always keep in mind in 2D, a vectorial relation will give me two equations, one in X, one in Y. In 3D, a vectorial relation will give me three equations, one in X, one in Y, one in Z, by doing comparison. Okay? So first, I will start to write each vector, the expression of each vector. For the resultant force, I know everything about it. I know its magnitude, so it's 1000 Newton. And I know its direction, it's from B towards O, so it's along minus K. So I can start by writing that Fr as a vector is equal to minus 1000 K. Okay? Now, for the other forces, what do I know about F1? I know that F1 is passing by point B and also is passing by this point here. Okay? So, as I told you, whenever you have a force passing by 2 points, to define the force, you should find the unit vector. And to find the unit vector, I need coordinates. Okay? So for point B, since it is on Z axis, the coordinates of point B are 0, 0, and D, where D is given to be equal to 3. So these are the coordinates of B. Now for this point here, you can call it, if you want, you can give the point a name. So since this is A, this is B, you can call the point here big C. Okay? So the coordinates of big C are, big C is on, point C is on x-axis, but it has a negative x component because it's going in the negative direction. So it will only have x, a negative x. And since this coordinate here is given, this distance is C, C is equal to 2. So we can say that point C has coordinates of -2, 0, 0. Okay? And finally, for point D, I will take point D here. For point D, if I look well at the figure and I follow the lines, point D is in plane XY. So this represents the Y component, and it's a negative Y component because I'm going towards D, I'm going in the negative direction, and it has a positive X component, okay? And A and B are given. So I can say that the coordinates of point D are, I have along X plus A, which is 1, and along B minus B, which is -2. So it's 1, -2, and 0. Okay? Now, once I'm done with the coordinates of all points, I am ready to write my vectors. Just for point A, I just know that it is in plane XY, but I don't know X and Y. So I will write the coordinates of A function of my two unknowns. So for A, it is X, Y, and 0. Okay? So now we should find 3 unit vectors. Unit vector of F1, unit vector of F2, and unit vector of F3. Okay? And then for each vector, let us do it, for example, let us start with F1. So if I want to write F1 as a vector, F1 as a vector is equal to F1 magnitude times unit vector of BC. Okay? F1 is known in magnitude, it's 500. So it's 500 times unit vector of BC is, I take x of C minus x of B, so it's minus 2I plus 0 minus 0, so it's 0 along J, and plus 0 minus 3 along K, so minus 3 along K. So this is vector this is vector BC. To obtain the unit vector, I divide by the magnitude, which is radical of 2 square, which is 4, plus 3 square, which is 9. This is how I get F1 vector. I do the same to get F2 vector and to get F3 vector. Let us see this in a clearer way here in the solution. So look, here they directly put all terms in a vectorial relation, okay? I just want you to know their way of writing. What they do is, instead of putting I, J, K, okay, they put them in columns. So this is, for example, for FR, we have written FR as the magnitude of FR times unit vector, which is 0, 0, minus 1, okay? So instead of writing minus FRK, you can represent it in this way. And for vector F1, it is the magnitude times the unit vector. What is the unit vector? As we have done, this is vector BC we have found together, okay? And we don't forget to divide by the magnitude. The magnitude is radical of C squared plus D squared. Now, since C and D are known, I just replace by their values, okay? I do the same for F2. I find the unit vector of F2, okay? And then I multiply the magnitude by the unit vector. This is vector. So if we go back to the figure, okay, we said that if we call this point D, we have found the coordinates of D. So unit vector of BD, okay? So this represents here vector BD. This is vector BD. And we divide by the magnitude. This is radical of A squared plus B squared plus D squared. And as you can see, finally for F3, okay, for F3's unit vector is BA, okay? So this is vector BA, and I divide vector BA by its magnitude. And you can see here that all are known except 3 terms, which are, first, I don't know F3, okay? And I don't know X and Y. So how to find these 3 unknowns? I do comparison along I, along J, along K, and I end up with 3 equations with 3 unknowns. Okay? Is the procedure clear, or you want me to go into more details? Any question on this problem? Okay. So let us continue with another problem. For this one, if you remember, we have done the same one in the slides of course material. So try to remember this problem and practice it again by using problem A. Okay, it's nearly same questions we did together. This is why I will skip it. Okay, problem 9. Specify the magnitude of F3 and direction alpha 3, beta 3, and gamma 3. So F3 is the resultant force of the 3 forces. So that the resultant force of the 3 forces is F. So as you can see, the style of question is the same. So just what we change is the forces. And if they gave us the resultant, so we can write a vectorial equation. And this vectorial equation can give us 3 unknowns. Okay? So let us see here what do we have. We have 3 forces, F1, F2, and F3. And the resultant, Fr, should be, is given. Look, Fr is given here. It's given as a vector with components. So they gave us this presentation. This presentation can be written as what? So this means that Fr has only a component along y. And I can write from this that Fr as vector is equal to 9j. Okay? So I know the resultant vector completely. Nothing is unknown about it. Now, what about the 3 other forces, F1, F2, and F3? So let us look together. For F1, I will put what they gave me. They gave me that the magnitude of F1 is 12 kilonewton. Okay? And I know also the angle it's doing with y-axis. So it's doing an angle of 30 degrees. Okay? So this is 30 here. So I know everything about F1, okay? Because if I look at my figure, F1 is in plane YZ, okay? So it has a positive component along Y and a negative component along Z. So from here, I can write that F1 vector is equal to the magnitude of F1, which is 12. Here, pay attention for units. All of them are in kilonewton, so it's fine. You can keep the relation in kilonewton. If you have several units in your problem, convert to 1 unit. So all forces are expressed on Newton, or all forces are expressed in kilonewton. So it's 12 times, along J, it's cosine 30, along J, and along K, it's minus sine 30k. Okay, so this is, if you want, this is the unit vector of F1, and once I multiply by the magnitude, I get F1 vector. Okay, so this is for F1. Now I move for F2. What do I know about F2? If we look at the figure also, and I follow the lines, I have components of F2 along parallel to X. So this is a component along X, and this is the component along Z. No components along Y. Okay? Now, what they gave me for F2, instead of giving me an angle, they gave me this information, C and D. Okay? To understand it better, let me draw for you a figure. If I give you a vector like this, and I put for you this representation like this. So here, the C is equal to 5, okay? And D is equal to, they gave me D equal to 12. This will allow you to find what? If I give you these two numbers, it will give you the slope, okay? It will allow you to find this angle. So giving these two numbers is equivalent to giving the angle here, okay? So no need, if you want also no need to find the angle. What you can do, you can say that if I have this case, okay, I can say if this is a right triangle, so if I do Pythagoras theorem, I get that the hypotenuse here is 13, okay? So I can directly say that if I call this angle that alpha, for example, if I call this angle alpha, then I can say that cosine alpha, what is cosine alpha? It is the adjacent length over the hypotenuse, so it's 12 over 13, okay? So no need even to calculate the angle, because I just need its cosine and sine. And sine alpha is 5 over 13, okay? So now, when I want to express f2, okay, as a vector, I can just write that f2 vector is equal to 10, which is the magnitude, times the unit vector. For the unit vector, it's given by cosine alpha and sine alpha. So I have, if you look at your figure, you have a negative x component, so you multiply the magnitude by minus cosine alpha I, so it's minus 12 over 13 I, while along z you have a positive component, so it's plus 5 over 13 k, okay? So this is your vector f2. Any question on how we found vector f2? Okay, so now I still have just the final vector f3. For f3, what do I know? I don't know anything, okay? So f3, because until now I don't have any unknown, f3 is completely unknown, so I don't know the magnitude, I don't know the direction angles, okay? So now, for f3, okay, the easiest way to write vector f3 is what? I can write that f3 as vector is f3x along I, which I don't know, plus f3y along j, which is also unknown, plus f3z along k. Okay, so these are my three unknowns. My three unknowns are the components of f3 along x, y, and z. Let us find them together. To be able to find these three unknowns, I need to write the set of equations. Okay, so to write the set of equations, I will start from my vectorial relation. What is the vectorial relation which will allow me to solve this problem? It is that fr vector, okay, is equal to f1 vector plus f2 vector plus f3 vector. And now I will replace each vector by its expression, okay? For fr resultant, it's 9j, so it's 9j equals 2. For f1, I already found f1, it's 12 cosine 30. So let me do the development. It's 12 cosine 30 j minus 12 sine 30 k. Now for f2, it's plus. For f2, I have minus 120 over 13 I and plus 50 over 13 k. And finally, for f3 vector, it's plus f3x along I plus f3y along j and plus f3z along k. Okay, now all I have to do is to compare The comparison along ijk will give me three equations. Let us start together. The first comparison will be done along I. Okay? So I will say by comparing first along I. Okay? So I have two sides. At this side, at the left side, I just have a j component. So this means that it's 0 along I, okay, and 0 along k. So I can say the first equation will be 0. 0 is equal to, what do I have on the other side along I? I have this term minus 120 over 13. And I have only also this term, which is f3x plus f3x. So from the first equation, what can I get? So I can get
F3x.
plus f3x, okay? So the only unknown here is f3x, okay? So I can say, so f3x from the first equation, I can deduce the value of f3x. So f3x is equal to 120 over 13, and the value is in kilo newton. I found my first unknown, okay? Here, just I will put it again. It's F3x. Okay. Now, I will do the same along J and K, okay? So let us, I will write here, because I don't have a space down. Comparison now, compare along J, okay? What do I have along J? First, from the first term, it's 9. So 9 equals 2. From the other side, the first term is 12 cosine 30. The second term is plus f3yj, okay? So plus f3y. So the only, also the only unknown in this equation is f3y. So f3y is equal to 9 minus 12 cosine 30. So I found my second unknown. The third step is to compare along K. So now I compare along K. What do I have along K? From the left side here, it's 0. So 0 equals 2. From the other side, I have first minus 12 sine 30. Minus 12 sine 30. And the second term is plus 50 over 13k. Plus 50 over 13. And finally, I have plus f3z. Plus f3z. Okay? So now, I did use that f3z is equal to 12 sine 30 minus 50 over 13. And I am done with vector f3. Now I know vector f3 since I have calculated f3x, f3y, and f3z. But what they want me to find, they want the magnitude and the direction angles. Okay? So of course, once I find fx, fy, fz, it becomes very simple because I know that the magnitude of f3 can be written simply as radical of f3x squared plus f3y squared plus f3z squared, and you know how to do it, okay? And who will tell me how I will find the direction angles? Which equation will allow me to find angles alpha 3, beta 3, and gamma 3 with the axis x, y, and z? What should I do?
We use the vector.
We use the cosine, okay? The cosine, because look, you know that cosine of alpha 3, look, what is alpha 3? Alpha 3 is the angle with x-axis, Okay, so if you remember how we defined the direction angles alpha 3, beta 3, and gamma 3, we said that since alpha 3 represents the angle with the x, so this means that if I do the perpendicular projection like this, I get f3x. Okay, so this is f3x. This means that I can write that cosine alpha 3 is equal to f3x over the hypotenuse, which is f3. Since I have here a right angle, okay? So since f3x represents the projection of the vector on the line, so in this right triangle, I can say that cosine alpha 3 is equal to f3x over f3 magnitude, okay? And since I know I calculated f3x, and I calculated also the magnitude of f3, I can now find alpha 3, okay? And I do the same for beta, where beta represents, so let me clear here the figure. Beta represents the angle, as you can see in the figure, with y-axis, okay? And gamma represents the angle with z-axis. So now, if we look at the calculation, so what they did, as we did, they wrote first the vectorial relation, but instead of putting them in vectors, they put them in columns. So it's the same method, just the way of representation is different. Okay, and by writing this, you will have directly a system of 3 equations with 3 unknowns, because the first line represents the relation along x, the second line the relation along j, and the third line the relation to comparison along k. So you can get a system of 3 equations with 3 unknowns. Now, as you can see here, you can calculate the 3 components, f3x, f3y, and f3z. We obtain that f3y is negative, okay? So we will deduce that beta 3 will be higher than 90, because we know that if you have a negative component, so the angle with the corresponding axis will be higher than 90. So to find alpha 3, beta 3, and gamma 3, we did cosine minus 1 for 9.2 we got. So if you do cosine minus 1 of 9.2, you get the angle with x, which is 15.5. If you do cosine minus 1 of minus 1.4, you get, of course, over the magnitude, okay? أكيد. لأنه when you want to find the angles, you should divide 9.2 by 9.6, okay? So this is, the first term is cosine minus 1 of 9.2 over 9.6. The second term, beta 3, is cosine minus 1 of 1 minus 1.4 over 9.6. And finally, you have the final angle is cosine minus 1 of 2.2 over 9.6. Okay, and if you want to verify at the end your result, you can verify by doing this. So verification, you do cosine square alpha, okay, which is here 15.5, plus cosine square of 98.4, plus cosine square of 77 degrees will give you 1. This is a way to verify your calculation. Okay, any question on this? So I hope all is clear. If you have any question about any problem here, let me know before we move to a new chapter. Anyway, when you study, if you face any problem, you can directly contact me. You can text me by WhatsApp, send voice messages, or if you prefer to do a session office hour, I don't mind. Just tell me and we can open an office hour. Okay? So now I will close this session, and open a new one to start chapter 3, which is on particle equilibrium. Okay.